All right, we're finishing up our Unit 5 trig review. We're on question 12. Use the figure below to determine, so we're trying to determine which equation would be used to find the length of S. Here's our reference angle. Let's label everything. Across from it is the opposite side. The hypotenuse is across from the right angle. And adjacent has no merit on this one. Okay, so ka, toa, and we're looking at opposite and hypotenuse. Opposite and hypotenuse. Sine of 15 degrees is equal to opposite is, I'll just write it out, opposite over hypotenuse. The opposite is 12. The hypotenuse is S, they're calling it. So sine of 15 degrees is equal to 12 over S times S times S. So S times sine of 15 equals 12. Divide by sine of 15. Do it to both sides to keep it balanced. And there's our answer. S is equal to 12 over sine of 15 degrees. 12 over sine of 15 degrees. All right, for which triangle? Okay. Is this true for? So we got, this is how I would do it. I'm just not sure, but I'm going for it. So we want to reference what the cosine of 62 looks like so we can apply the SOHCAHTOA to it. So I'll divide by 12. Divide by 12. 12s cancel. And I get x over 12 is equal to cosine of 62 degrees. So, ka-toa. Cosine is adjacent over hypotenuse. Adjacent over hype. All right. So the hypotenuse is 12. The adjacent is x. All right. I think that's the way to go is, man, they're rolling these all around. So the hypotenuse is kind of the easiest one to make out. That doesn't change depending on the degree. So it could be this one, or it could be this one. Those are the ones that have a hypotenuse of 12. That's not a hypotenuse. That's not a hypotenuse. So not these. All right. And then we're looking for an adjacent that's x. Nope, that's an opposite. An adjacent that's x. So there we are. Next one. All right, they're giving us a table again. Let's try not to forget this time. Calculate the length of LN. LN. So they want this side right here. I'll call it X. Angle of reference. They're giving us the 6 as an opposite. OPP. And then here's our hypotenuse as our X. So this would be SOHCAHTOA. And opposite and hypotenuse is sine. So sine of 37 degrees is equal to opposite over hypotenuse. And opposite is 6. Hypotenuse, well, it's another letter on the bottom. Joy. Boy, they've given it a lot of these. And it is the tougher one. So I'll go ahead and just flip both sides. Kind of changing up my methods each time. 1 over sine of 37. H over 6 times 6 times 6. 6 over sine of 37 equals H. And then we'll calculate. Oh, there it is right there. Sine of 37. So we want to approximate h is approximately equal to 6 over sine of 37.602. It's a decimal. 0.60, and that's a 2. Yep. 6 divided by 0.602. 6 divided by 0.602. 9.9667. 9.9667, I think it was. And that's 2 decimal places, so look at that. That rounds up. 9.97 is the approximation. Yay, last problem. All right, which equation, okay, just an equation, good, correctly solves this triangle for x? Angular reference, this is the adjacent side, this is the hypotenuse side, so katoa, adjacent and hypotenuse. Cosine of 61 is equal to adjacent is x, hypotenuse is 13. X over 13, cosine of 61. X over 13. All right. Hope you did good at this. I recommend going back through and checking your answers and compare them to mine.